Good evening and welcome everybody to the June 2022 Novice Meeting of the Houston Astronomical Society. My name is Joe Califf. I'm the president of HAS, and I am delighted to have you all with us tonight. Our presentation tonight is one that I'm looking forward to quite a bit because I've got to figure out what I'm going to do for the Great Texas Eclipse of 2024. And we have an annular eclipse that's coming up next year. So I'm going to try to get as much information as I can from our guest speaker, Miss Debbie Moran. Debbie is the Novice Chairperson here at the Houston Astronomical Society. And she's had a lifelong interest in astronomy since her childhood in Midland, Texas, where all the scenery is in the sky. She's been a longtime member of the HAS and has served in a number of capacities here. She's been our Novice Chairperson for quite some time now. She also participates in outreach programs and is a volunteer telescope operator at the George Observatory in Brazos-Penn State Park. She is the 2017 recipient of the International Dark Sky Association's Hoag Robinson Award for Education of Government Officials about outdoor lighting issues. She continues to beat that message into the heads of our elected officials. So hopefully that's starting to take root. It sounds like it is. In 2010, her Woodside neighborhood became the first one within Houston city limits allowed to install low glare, fully shielded decorative streetlights. For the past 4 years, she has presented concerns about the choice of high glare white LED streetlights in Houston to city officials in hopes that the Houston area will someday join other communities in moving to warm or soft white or to amber LEDs, which are recommended by the American Medical Association for the reduced glare and reduced disruption of date-night circadian function. A lot of other benefits to that kind of lighting as well. But without further ado, I'd like to pass the microphone over to Debbie. Debbie, take it away.
So thanks very much, Joe. So I'm talking about one of my favorite subjects, which is eclipses. And I always wanted to see one since I was a child. So once I saw my first one, I got hooked not only on the eclipses themselves, but on the travel. And I'm going to do this talk kind of in two parts. The first is going to be just about eclipses in general and how they work and why we have them. And the second is going to be about planning for this particular eclipse, specifically how I think about when I plan an eclipse. And although there's plenty of, there's not a huge difference throughout Texas on weather, but I'll let you know my thinking, even when I'm on an organized tour and there's a choice of places. Sometimes I have 2 or 3 possible buses going to different areas. I have a way I think about that, and that's actually been pretty successful. If one group sees it and one doesn't, I'm generally in the group that does see it. So I would like to go ahead and share my slides. Let me go ahead and do that, start my PowerPoint.
Debbie, while you're doing that, I just wanted to remind everybody that if they have questions for you at the end of the presentation, go ahead and use the chat function within Zoom. We'll collect those questions and we'll get to them in the order that we receive them.
Okay, so everyone can see my first slide here?
We certainly can.
Okay, I'll go ahead and carry on. So the eclipse that we are concerned with specifically is on Monday afternoon, April 8th, 2024. And I'll explain why I say a miracle occurs shortly. But I want to strongly urge all of you, even though you're close, you're in Houston where we'll have a 94% coverage of the sun. That's not good enough. And I'd like to encourage you to have the best possible experience under totality. We have a rare opportunity to see it close to home. So I just want to let you know, there are a lot of us who spend thousands of dollars to go to the other side of the world to see eclipses. So you definitely want to take advantage anytime there's one close to home. Oops, I need my keyboard to advance slides here. Okay, so first of all, what about eclipses? So who goes sees them? What are they? How do you go see one? Where are they? And why? That I will definitely explain why. And there are going to be some helpful websites which I'll mention throughout the talk. I just want to let you know you won't have to remember them because I will have a final slide with all of those information about how to reach all of those websites, and I'll leave it on long enough for you to take a screenshot. So first of all, what is a total eclipse of the sun? Well, it's one of the most phenomenal spectacles in nature. And I don't show a lot of either video or photographs of total eclipses because I have yet to see one. Even though technology has gotten better, I still haven't seen anything that's like the personal experience of it, of seeing it in person. So this is a very nice photograph. You'd get some detail in the in the corona there surrounding the moon, and that's approaching what you see with your eyes as far as the corona, but there's a glow to it that you see in person that you're missing, and also the sky is not black. And we're getting better with the photography. The other thing is, not only do the pictures not look like the eclipse, but eclipses are not static. They're constantly changing while you're watching them, and there's a lot that happens in a short time. So all I can say is that don't judge whether to go to an eclipse by a photograph or a video, because it's nothing like the real thing. We have gone on trips where our tour guides have wondered, why in the world are we going to all this trouble? And usually they've seen photographs and they think they know what one is, and then every time they see one they say, oh, now I get it. So I hope you'll try to get to this one. So these were eclipse chasers. This actually was not an eclipse trip. It was a transit of Venus trip in the stands. But these are all people I have traveled to eclipses with before. And you will find that if you do decide to chase eclipses on a regular basis, you will start running into some of the same people. It's a passion that a lot of people share. And if you go beyond Texas, you'll find that a lot of the appeal is the world travel also. So why do we do this? Well, basically, you're seeing one of the most astonishing miracles in nature. So we have a single moon. We don't have a lot of them like Saturn and Jupiter. And it happens to be 400 times closer to us than the sun, but is also 400 times smaller. What that means is that we have an apparent size of the moon and the sun, which are very, very similar. And without that similarity, you can't have the beauty of a total solar eclipse, in which you blot out the sun's surface, but you see the corona around it. Now, it turns out that this can't happen every single month, because the moon's orbit is tilted about 5 degrees to the Earth's orbit around the sun. That means that most of the time we have, at new moon and at full moon, the shadows miss each other. So often the moon is too high or too low. It's compared to the sun for us to have an eclipse. So there's a point where these orbits cross, and the moon and the sun must coincide at those points called the nodes for it to be possible to have either a total lunar eclipse like we had recently, or a total solar eclipse. And we have many more total lunar eclipses because the Earth's shadow relative to the moon is a lot larger than the moon's shadow on the Earth for a total solar eclipse. So this is another diagram just showing you how this works. If the moon is lower or higher than the sun, you just get full moon and new moon. But if it's on the nodes, you now have the possibility of an eclipse. And you will have eclipses, a lunar eclipse and a solar eclipse, 6 months apart, anytime that we are in that kind of configuration. So the other thing we need to know is that there are several kinds of eclipses, and that's because the apparent size of the sun varies, because the Earth's orbit is not circular, it is elliptical. So sometimes we're a little bit farther away from the sun, sometimes we're a little bit closer. And that's even more so for the moon going around the Earth. So sometimes the apparent size of the moon is larger and sometimes it's smaller. When we talk about these supermoons that get into the news, all they're talking about is a full moon that coincides with when the moon is also especially close to us. So it's a little bit larger full moon than usual. That's what they're talking about. When it comes to eclipses, this means that sometimes the moon exactly covers the sun, sometimes it's a little bit larger and you have a longer eclipse where it's total, and sometimes it's a little too small to cover it completely. So we're going to go over those types of eclipses. So if you have an annular eclipse, what we call an annular eclipse, like in the diagram at the right, it's the lower right image. This is when the moon gets in front of the sun, but it's a little too small to cover it completely. So they call this ring of photosphere around the moon an annulus. You don't get any corona, but you do have a very pretty view of a black new moon, because we're looking at its nighttime side when it's covering the sun. Its daytime side is facing the sun. So you get this beautiful view. And when it's big enough to the size to cover the sun, then you get the real show, which is the corona and a parade of prominences that look like little bits of red laser light around the edges, appearing and disappearing as the moon proceeds across the surface of the sun. So this combination of sizes means that the longest possible total solar eclipse is about 7 minutes and 31 seconds. And also, there's a different length that you can have with annular eclipses. According, if the moon's really small, it takes quite a bit of time to cross over, or at least a number of minutes to cross over the sun's surface. This is an annular eclipse. This is a beautiful one that was in Texas, and it's an especially beautiful one to photograph. This was done by Joe Dellinger in far west Texas. This can make a very beautiful picture when the sun is low in the sky and you get some landscape also in there. That also increases your risk of missing the eclipse on a partly cloudy day, so I will explain why a little bit later. Now we have the chance to see an annular eclipse similar to that one also in Texas on October 14th, 2023. And the map I'm showing you, I will talk about this website a little bit later, is by Javier Uba, and I will spell that for you later. And he has these wonderful interactive Google Maps where you can drag the map and you can enlarge it to whatever you want, even down to individual houses, and click on that spot and get all sorts of data about how you will see the eclipse. So how high it is above the horizon, what direction you're looking, what the times are. It's really a wonderful resource. And I'm not going to talk too much about this one. I just want you to know it exists, but I'll let you know how to find that map in the future so that you can make your own plans. Do notice that Albuquerque, I've already made plans, Albuquerque is one of the biggest cities that's exactly on the center line. And that's a desirable place to go weather-wise, which I will show you in a minute. And they are having the balloon festival is going to be coinciding with the eclipse. So if you haven't done that before, it's a great time to go to Albuquerque for the October 14th, 2023 eclipse and explore New Mexico a little bit. It also goes over some spectacular sites in Utah, including one of the national parks. And so it covers a lot of beautiful areas. You can get to these on your own, but there are some pretty high caliber tours. I know my tour operator is operating one where they'll take you to a lot of the most beautiful sightseeing along the path. So this is a map of the average cloud cover. There's a man named Jay Anderson, who's the eclipse weather guru who compiles these things. And what you see on the left in decimals is an average total or sky coverage. So if you see 0.7, that means 7/10 of the sky is covered on average. And you're looking for cities when you're planning an eclipse down low, where the average cloud cover for that time of year is lower. So you want to have a lot of the sky clear, or a lot of those days likely to be clear. So for this particular eclipse in 2023, the best sites are Albuquerque, parts of New Mexico, and parts of Utah as far as weather goes. The points you see outside of this line, anything that's right on this squiggly line is close to the center line. You don't have to be on the center line to see an annular eclipse, but it's the prettiest picture when the moon is centered on the sun. For us, the closest place to go would be, say, San Antonio and Corpus Christi, but you can see the risk of clouds is somewhat higher. So the solar eclipse shadow is actually quite small for a total eclipse of the sun. So it covers a very small part of the Earth. That's why it usually requires travel to see a total eclipse, because you must be within a skinny black line to get totality. There's a much larger area, this penumbra of the moon's shadow, which is where you get a partial eclipse. So lots of places you can see a partial eclipse, but very few places you can see a total eclipse. So again, this light gray corresponds to a partial of some sort, and only the dark black line corresponds to a total eclipse. Within that dark black line, there's a center line. So for the longest totality, we want to be as close to that center line as possible. On the edges, the eclipse is total, but it's shorter. This is what the moon's shadow on the Earth looks like from space. So we get these wonderful pictures. This was from the 2006 eclipse in Turkey. So every time there's an eclipse, there's usually some kind of space station photo of the shadow on the Earth. And there's something called a Saros cycle, which is a combination of 3 different cycles, which are very, very irregular. There's the time from new moon to new moon, the time from perigee to perigee, so that would be closest approach, and then the time from node to node. And that results in something called a Saros cycle equal to 18 years, 11 days, and 8 hours. And what that means is those eclipses have similar characteristics. So the very longest eclipses can be about 7 minutes. So if you see one of those, it might be 18 years before another one of these super long eclipses rolls around of a similar length. So that means that the apparent size of the sun and the apparent size of the moon are similar on that cycle. Because that little 8 hours at the end of this calculation, it means that to see a similar eclipse 18 years later, you must travel 1/3 of the way around the Earth for its location. So someday there will be no total eclipses. We're very lucky to live on a planet that even has this, and we're also lucky to be living at a time period that this is possible. So because of tidal forces, the Earth's rotation is slightly slowing, and the moon is gradually speeding up, and it is receding from the Earth about 3.8 centimeters a year, about 1.5 inches. What that means is you need to hurry, because the last total eclipse of the sun will be only 620 million years from now, so make sure you get to one soon. After that, the moon will be too small to cover up the sun, and we will have only annular eclipses. Now, there's something also called a hybrid eclipse, and we have one of those also coming up in 2023. So in 2023 and 24, we have annular, hybrid, and total. And a hybrid eclipse is one where the moon's apparent size is so close to the sun's apparent size that it actually makes a difference where on Earth you are. So if you're curved away from the path, you actually get an annular eclipse. You're just a little too far away for the moon to cover the sun. But if you're very close to if you're in the center of that path, you are on part of Earth that's a little closer to the moon, and now it covers the sun. And what that means is that the total eclipse is fairly short. So I believe the longest totality you can have with a hybrid eclipse is about 1 minute and 49 seconds. So that will be true between 4000 BCE and 6000. Now, why would you travel to see such a short eclipse? Well, it turns out that when you go see an eclipse that maybe lasts only seconds, instead of seeing all these beautiful prominences sequentially, like you see them appear on one side and then they get covered up and you see them appear on the following side, you see them all at once. So you end up with an incredibly beautiful, what we call inner corona, and that's visible to you. The camera needs to take a very short exposure to see it, and it can't capture the outer corona, but your eye sees this plus the outer corona all at once. I've traveled to one when we had to flee clouds a little bit. We ended up at only the 10-second point in Uganda, and the longest it was going to be on land in Uganda was 23 seconds. And this is a quick digital SLR, point at the sun and click, and Chris Treasel got this beautiful photo. So of course we didn't go there just for the eclipse, although it was exceptionally beautiful for our 10 seconds. We also saw gorillas and saw beautiful, actually it was one of my best trips. So we straddled the northern and the southern hemispheres, and they have spectacular parks. Uganda is actually an incredibly beautiful country. We had got all the animal watching. So I would like to mention there's no guarantees with eclipses. You can have clouds. You just do the best with your weather statistics. But you also want to make sure, if you're spending a lot of money to travel, or if you're traveling anywhere, part of your calculation of where to go might be to make sure you get a good travel experience, just in case. So we do have a hybrid eclipse on April 20th, 2023. And a lot of the travel here is quite expensive because it's either to Indonesia or Australia. There's a teensy-weensy piece of land it goes over, and there's a lot of cruises in the ocean to see it. The longest on land is about 1 minute 10 seconds here, but it's the sightseeing is very nice on these. I may skip this one because of its expense, but if you haven't been to Australia or to Indonesia, this could be a very good travel experience. So one thing you need to know before I show you some data on eclipses and how to find it for your location is certain terms. So they call the very first moment that the moon takes a bite out of the sun or just contacts its edge is called first contact. Then you have the partial phases. Second contact is when the moon reaches the far edge of the sun, and that's the beginning of totality. That's when you begin, that's the point at which the entire photosphere is covered and you see the corona. And you will see that through what we call mid-eclipse, when the moon is midway through its path and centered on the sun. And then fourth contact is when the sun starts to reemerge. The moon finishes crossing over. So you can think of these as points of contact, kind of tangential contact between the edge of the moon and the edge of the sun. So for a partial eclipse, it never completely covers the sun, but there's also some terms for that too. So this is just some diagrams, first a diagram and then actual photographs of these stages. So we always get excited when we plan something 2 years in advance, and then you see this tiny little notch exactly where it's supposed to be at the exact right time for where you are. That's first contact. The partial phases are interesting, but they're especially interesting if there's a lot of sunspots on the moon. If you have something like a telescope or even binoculars, but especially a telescope, a small telescope, and you have a solar filter, when there's sunspots present, you are best able to perceive motion of the shadow. So anytime you have some kind of reference point that's very close together, it's fun to watch the moon cross over a sunspot. Without that, it's a lot harder to perceive the motion. You can look several minutes later and see the moon has proceeded farther along, but you don't literally see that motion. So this is second contact. This is a small diamond ring in this photo. What we have something called the diamond ring, which is when the last bit of photosphere disappears. At this point, it is safe to remove all solar filters and to look with your naked eye. So from the diamond ring on, you do take off any eclipse glasses, uncover your camera, and it's safe to look. For children, it's safe to look. What's dangerous about an eclipse is that when it's almost covered, it almost gets comfortable to look at, but it's still very unsafe. That's a danger. When the sun is completely uncovered, most people will just instinctively look away very quickly. The danger is when there's only a little bit left, and as a child, they might stare at the sun, and that's where I actually have a friend whose father did that when he was a child, and he had a blind spot in his vision for the rest of his life. So if you have children with you for an eclipse, have close to a one-on-one ratio of adults to children, especially small children, and watch them, make sure they are safe during the partial phases. On the other hand, don't be overly afraid. I suppose when these schools don't let people out to see an eclipse, it may be because there's not enough adults to supervise small children, but with enough adults, you want the children to go out to an eclipse. This is the following diamond ring. So this would be, we've had first and second contact. This is third contact. And then hardly anyone sticks around for fourth contact. That's when the sun is fully emerged. There's no more partial phases. But some people want a picture like this. So there are people who want entire series of all the partial phases, totality, and all the following partial phases. That takes about maybe 2.5 hours, 2 to 2.5 hours to stay out that long to do that. So observing eclipses safely, with any equipment, you want to have a filter that's designed for solar observing. So the one you see here, which I've been carrying around with this is still a film SLR camera. The reason it's larger, and I found that to be an advantage actually, is that this is the solar filter for my 5-inch Schmidt-Cassegrain telescope. But I put some layers of, built up some corrugated cardboard so it could also attach tightly to my camera. And I kind of like that because it shields the body of the camera. There are companies that make these solar filters. They're called neutral density filters, which are out of glass and block out something like 99.99% of the sun's light, and it looks like a yellow surface, and you can look safely through them. There's also welder's glass. Normally you would want number 14, but there's a lot of unsafe ways to look at eclipses. You don't want to look through a compact disc, a CD, or aluminized food packaging. I have admitted to doing that with space blanket, but multiple layers of it. And but it's not a safe way to, it's not a guaranteed safe way to do it. Exposed coated film, smoke glass. A lot of people won't get the proper equipment. It's very inexpensive, definitely worth ordering ahead of time and having what you need. The other thing is when you're using equipment, and by the way, I'm showing you equipment, but if this is your first eclipse, don't worry with the pictures. Maybe take a point and shoot and get kind of a global view of it, or maybe set something up on video and take a picture of the whole scene. But I'll explain why you don't want to waste too much time with pictures. This one is a longer eclipse, it's a little bit more possible, but first of all, you pretty much need a telescope to get really spectacular photos, and it's still not going to look like what you see with your eyes. This diagram is to show that you don't want any filtration on the back end, like toward the eyepiece end, because the sun's rays will destroy your equipment if it waits until the eyepiece to finally hit a filter. You want any filtration completely in front of your camera or your telescope. Well, how do you aim it? You actually don't want to use any kind of finder. In fact, I usually remove my finder. It's not that easy, but what you do is you use the sun shadow to make the smallest, roundest shape with your filter on the ground. And then I usually use a right angle type of viewer, and so I'm never looking directly toward the sun, and I do a little trial and error shifting once I've done this, and I usually find the sun that way. I do recommend, if you're really serious about photos and want to do that sometime, there are devices which will follow the sun, because trying to reacquire the sun repeatedly during a long eclipse will distract you and not be as easy to do. You could conceivably do that, but I would recommend there's devices like Sky Patrols, which are like clock drives for your camera or for your telescope, and drive your telescope to take any pictures. There's now so much automation. I've seen one guy set up 7 tripods and 7 cameras, and everything was automated, and then he just sat back and watched the eclipse. But that can be an expensive setup. If you are taking photos and you're shifting between the partial phases when you need that filter, and then there's a stage called Bailey's Beads, which I will show you a little bit later, where the moon's almost completely covering the sun, and the sun's light is coming between the mountains of the moon and breaking up into what we call beads of light. At that point, you want to remove your filter, but when you do that, your camera will shake. So what you do is you put some kind of barrier, not an Astros cap actually, because it has holes in it, but some kind of opaque barrier, like a hat that doesn't have any holes in it, or a piece of cardboard. Remove the filter, keep the cardboard over your camera or your telescope until actual totality. Then you just move it to the side. There's no vibration of your camera, and you can take your totality photos. We also, if you're interested in doing photographs, recommend using a kind of an automatic shutter so that your finger can shake the camera. There's all sorts of things, advice on that. I'm not going to focus too much on photographing, because I've actually stopped trying to do that. There are so many things to see in an eclipse. You often can't do it all in one eclipse. Sometimes you have to focus on something differently. So definitely just watch it. I'm going to show you my first 4.5-minute eclipse, which was my very first one in Indonesia, and what I did, and it's probably the eclipse I still remember the best. There's also eclipse glasses for direct viewing, and I believe the most reputable dealer is called Rainbow Symphony. Go to rainbowsymphony.com. They'll also custom make filters for binoculars, which is a great way to see an eclipse. And they'll make them for, say, specific camera lenses, and it's very easy to order for them. Just don't wait until the week before the eclipse, because there'll be very high demand. So this is actual people wearing eclipse glasses. These are, I've actually kept in touch. These are some women from the Philippines. The one on the left has been living in Los Angeles for 30 years. I met them in Australia on the way to Lone Pine Koala Preserve. They travel independently, and Emma now went to Uganda with us, which was independent travel, and I'm meeting her in Albuquerque. Trude is still in the Philippines. That also, if you travel to different cultures, they often make special eclipse glasses for sort of a memory of that particular culture. This one was sold on Amazon. Amazon does sell good eclipse glasses, but they also sell counterfeit ones. So you have to be very careful with Amazon. If someone makes an eclipse glasses that don't have good filtration, that could be a little bit dangerous. One way you can test glasses is first make sure there's no holes in them. A very good filter, it'll be very comfortable to look at the sun, and the sun will have very sharp, hard edges. If there's sort of a little bit of haziness to the sun, do not use those glasses, or fuzzy edges. Then there's the colander trick. So if you're with kids, a very safe way to look at the partial phases. You can get very clean partial pictures of the partial phases. I wanted to show you this picture to show how it's done, but this is not the greatest picture, but this is done with a steamer with holes in it. So I've found so far that every Airbnb I've stayed in has had a colander or a steamer, and we just take that outside to project partial phases for any children present. Now let's talk about the travel. So first of all, one way to do it is to go on with an experienced tour operator. They will give you a first-class experience, great hotels, fantastic sightseeing. It's one of the more expensive ways to see eclipses, but if you want to have everything done for you and to have experienced people who will help you with the eclipse, this is the way to go. And they will do their best to get you to a clear spot. So they will, usually these trips are planned for the places with the best chances of seeing the eclipse, and then they often have multiple possible places to go, or the ability to chase, to dodge clouds a little bit. So this is my favorite tour operator, eclipsetours.com. And this is Paul Maley and his wife Lynn, who actually married him because I couldn't go on an eclipse, and she took my place and they met there in 1994. So, but for something like this in Texas, you can also plan it yourself. So that's considerably less expensive. So when I planned an eclipse to Chile using Airbnb, the total, including airfare, was a couple $1,000s. Without airfare, my tour operator was doing a very fancy schmancy $7,000 trip, and that was before buying the airfare. So definitely self-travel can be good if you feel like it's a country that's comfortable enough to work with, and there's English speakers there. We did a wonderful Airbnb with a wonderful host in 2019 in Chile. And in Uganda, we went with, there's just 6 of us, and we went with a company that plans African tours, and so we were shepherded through Uganda, but we didn't go with a big tour. So to plan it yourself, the first thing to do is make sure you have the time off. So this particular eclipse, totality happens at 1:30 p.m. on a Monday afternoon. So it's entirely possible to, that morning, check the weather, leave Houston, or I should say very, very, very early morning, maybe midnight the previous night, and proceed to a good site in Texas. The problem with doing it that way, the good thing about that is you take minimal time off. The problem is that that's when all the major traffic jams are. So someplace that might normally take 3 or 4 hours can take 10 or 13 hours to get to and from. It's like fleeing Rita, the hurricane. It can be that bad. Fortunately, in Texas, we have a lot of different places to go. So if there's a lot of clear places, it might not be quite as bad. But if there's a 1 or 2 obvious places to go for weather, the traffic could be terrible. What I do recommend is if you can actually take a vacation then to do it. So you want to, if you're working, it's possible you're working for an office that can't let everybody off at once. So as soon as it's time to ask for vacation for that particular year, you want to be the first person to ask for it, so that so you have a good chance of getting that particular time off. If you have time for a little bit of vacation, try to leave on Tuesday, get back, try to have Tuesday off also. You will avoid the worst of the traffic jams getting back to Houston. Also, get your kids out of school. I don't care if they're not letting school out, or they say, well, we'll take them out for the partial eclipse. This is often a once-in-a-lifetime experience, and they can make up the homework. Kids are sick, and they make up homework, and they survive. But if they miss something like a total eclipse, it would be a real shame. This is definitely one of those things you just take kids out from school And maybe some schools will let them do a report on it, but do civil disobedience if you have to and get them out of school to see this eclipse. And what I like to do is get housing on the center line for best comfort. At least have that option, even if it turns out to be a cloudy place. If there's a chance of having a very comfortable place to observe the eclipse, do it. Because if you're one of the people on the road, bathrooms get scarce, the comfort level is scarce. You may be on the road for hours and hours. It might be hot, but I don't think it will be at that time. But it's so much better to have all your infrastructure around you and be in a comfortable space and have food and comfort with you. So if you can do that, do it now. And the reason I'm giving this talk 2 years in advance is because your chances of doing that along the center line affordably are now. As you get closer to the eclipse, the price gouging starts to happen. Even small podunk hotels will start raising their prices. And that's actually worst in the most desirable vacation spots. So the worst price gouging for the 2017 eclipse was probably in the Grand Tetons area, because you had the combination of the eclipse, great weather prospects, and fantastic vacation. So the house that we got 2 years in advance, similar houses were 4 times that. By planning 2 years in advance, we had a 7-bedroom, 5.5 bath house on a golf course community for amounting to, I think it was $600 a night. And I offered the guy a little bit more as it got closer. He said no. We created a lot of goodwill, but similar houses were $2,400 a night. So now is the time. So how to choose a place to see an eclipse? Well, first of all, you want to look at weather statistics. I should say there's no guarantees on that day. So for the 1991 7-minute eclipse, I had a roommate who happened to be in a Spanish program in Cuernavaca, Mexico, which is in the mountains where there was a 90% chance of being clouded out. She had a cloudless sky that day, and I had sent her some eclipse filtration, and she said they were very popular, sharing it with people over there. My boyfriend Matt Delavorius was in Baja, which had one of the best weather prospects. Perfectly clear day, but right before totality, some thin cirrus formed in front of the sun. Not enough to completely diminish the experience, but enough to have a little bit of wispiness over totality. I was in a partly cloudy area on the west coast of Mexico, which worked best with my symphony schedule at the time, and we had this large oval cloud over the partial phases, kind of translucent. We could still see the sun. 7 minutes before totality, it cleared out. We saw totality for all 7 minutes, completely in the clear, and then the cloud reformed right after totality ended. So if you have a partly cloudy sky, what you might notice is that often clouds will change for the better or worse because of the temperature drop. You can often have seems like typically I've been experiencing 16-degree temperature drops at totality, or often a little bit of a lag time shortly after totality. Also, I mentioned check local terrain. I will show you why in a few minutes. You want good accessibility. Is there a way to reach the site on a road? Of course, in Texas, that's not a problem. You want proximity to the center line, because the farther away you are from the center line, the shorter the eclipse. So at the center line in Texas, it ranges from about 4 minutes and 25 seconds to 4 minutes and 30 seconds of totality. This is so long that even halfway to the edge is still about 3.5 minutes. Dallas is about halfway between the center line and the edge and still has the 3 to 3.5 minute range, still longer than even the very best totality in 2017. So the ideal is a house on the center line or very close to it. You also want a cool place to visit. You want some kind of nice experience because there's always a chance of being clouded out. This is Texas in April, so there's definitely a chance of being clouded out, but we have a decent chance of seeing it. And for some eclipses, people prefer cruises, although that doesn't always work because they have the mobility to chase, good mobility to chase to a certain extent. Ships don't move all that fast, but they will make an effort to get to a clear spot in a somewhat cloudy day. This is Javier UBA's Google Earth eclipse site. And I usually find the best way to find his site, rather than knowing the exact URL, which is kind of long, is just to do a search for Javier UBA and either interactive Google map or the year of the eclipse, like 2024. But there's a page he has with all eclipses, past and future, for many years. If you scroll down, at first you see the total eclipses, you scroll down, you'll see the annular eclipses, partial, and what's wonderful about his maps is that you can blow them up, and I'll show you how that works in a minute. But for Javier Ubier's, just you need to remember the spelling of his name. He's a French Canadian, and or actually French, I think. And this is the best resource out there for planning an eclipse. Still, you can have the best made plans for clear skies, for clouds. You could still have wildfire problems. Fortunately, in this Zambia eclipse, the sun was on the other side, but for some reason, people decided that was a great day to do controlled burns, the farmers out there. So that's a risk. And that was also a risk for the 2017 eclipse. So the clearest places had the most wildfire risk because they were out west. So getting the most out of an eclipse, plan your experience ahead, decide what you're going to focus on. There's a lot of things to see. So you might want, shortly before totality especially, you might want to turn your head in the direction of the approaching shadow so you can see it coming at you. Sometimes that means turning away from the sun, as it did in Idaho in 2017. It takes a little discipline to do that, and then looking back at the sun just as the diamond ring comes on. You might look for something called shadow bands, which is when there's just a little slit of sun left. You have a phenomenon that happens sometimes on the ground, and you need a light colored surface to see it, but it looks like ripples on a swimming pool. It looks like alternating bands of dark and light shadows moving slowly across the ground, and it's pretty striking. You might want to focus on Bailey's beads. So if you're doing that, you're missing the shadow bands and the shadow. You might want to look around at all the sunset colors. There's so much that happens in a short time. Norm Sperling gave a talk years and years ago. He was a California amateur, to the Houston Astronomical Society before I ever saw my first eclipse. And what he said has turned out to be true. I remember he said back then, no matter how long the eclipse is, you'll swear it was only 8 seconds at the end, because a lot happens in such a short time. It seems to go by very fast, except for the 7-minute eclipse I saw. That actually seemed to last for a while. So his solution is interesting, because I tried doing what he says is the wrong thing to do. I saw a 4-minute eclipse, and all I did was stare at through my camera lens, which gave me something like a binocular view for the whole 4 minutes, just to watch the corona. And it felt like 8 seconds. Norm says, don't do that. Do a variety of experiences during the eclipse. So don't just stare at the sun itself the whole time. And his theory is that if you have one image in your brain, your memory compresses that to a single experience that lasts a very short time. So he was right. I saw a 2-minute eclipse in Australia, and in those 2 minutes, I looked at sunset colors. I looked at the sun with naked eye. I looked at the sun with binoculars. I did a very quick sketch of the outer corona, at least the basic shape. Not enough time to do a detailed sketch. I did a quick point and shoot with my camera, and it felt longer than the 4-minute eclipse. So I just want to talk about my first eclipse, because I think it may be one of the ones I did the very best as far as what I was observing. We've called people who've never seen one eclipse virgin. So I was an eclipse virgin. It was 1981, I was planning it. So that's 2 years before the eclipse. It was in 1983. I was just out of college and talked my parents into going to Indonesia and taking me. So I thought the $3,000 at the time was just an enormous amount of money to spend in 3 weeks. I'm glad I learned early on that spending money on experiences is a much better way to spend it than on stuff. So that, even now, that 1983 experience sticks with me. So what I did was I wrote down what was happening. My group was on top of the hotel. Others did a 3-hour drive to a more rural area. They thought they would get a lot of animals, but they said there were so many groups doing that, there was not an animal in sight. Meanwhile, we had the zoo, so we had roosters crowing in the city, so we had lots of animal experience in the middle of Surabaya, Indonesia. So I wrote down what I saw. The light turns eerie, so as most of the sun gets covered up, it's kind of a dusk-like thing, like light, except it has an unnatural clarity to it that you don't really see at a regular dusk. The temperature drops, especially in the last 20 minutes or so. I saw street lights come on. Then we had 20 minutes of zoo animals braying and crowing and roosters crowing, all sorts of things happening. Then I noticed the shadow of the moon start to darken the sky, and it swings in a large arc from one side to the other side of the sun. At mid totality, it looks like a huge kind of black arc centered on the sun. I saw sunset colors all around, and then I think there can be shadow bands. I don't think I saw them at that particular eclipse, but the time to look for them, this is looking down at a light surface. So sand is great, or bring a white surface. Sometimes if I will choose a site where there's white buildings. We had great shadow bands in Chile with white buildings and the light colored sand. But if you don't have that, what people do is they bring a white sheet or a white towel and put that on the ground to see shadow bands. The most spectacular array of shadow bands was in the Libyan desert, which was like a gigantic parking lot in eastern Libya, and the entire desert came alive with shadow bands. This is Bailey's beads. So I believe these are by Richard Nugent, who used to be a member of the Houston Astronomical Society. And he travels actually to the edges of the shadow where the Bailey beads effect is the most pronounced. And they are able to get quite a bit of data on the shape of the edge of the moon. When they do that, it's sort of a scientific expedition. And they say that this prolonged effect of beads constantly forming and unforming over a long period of time, they say is also very, very beautiful. But you get that for a short time if you're near the center line, and just for the length of time it takes the moon's mountains to divide the edge of the sun into beads, and then pretty soon the sun's completely covered up. So these are my notes in Surabaya, Indonesia. Loudspeakers advise, oh yeah, we had, it was a Muslim country, so loudspeakers were telling the townspeople not to look up. The first rooster crowed at 10:53, so I see that's this is like a good 40 minutes before totality. The animals in the zoo got excited. There was chanting from the mosque. There was a spectacular diamond ring that lasted for several seconds. And then when the corona came out, I was stunned. It's still the most beautiful corona I've seen. It looked like a flower with long petals and regularly shaped, but amazingly long petals that seemed to go on for a long period of time. There was also, wasn't expecting the prominences that looks like someone had turned on a red laser. Sometimes it's pink on the edges of the sun, these little bits of red light. You can see only the brightest objects in the sky. So you can see bright planets and the brightest stars because it only gets a dusk darkness. You don't get a black sky. And so usually you can get maps of the sky. I'm afraid I didn't bring one. Didn't think about getting that for 2024. But there are people who will prepare maps for your location of what bright stars and planets might be out during totality. So I sketched it, and now I recommend everybody sketch the eclipse. In a 4-minute eclipse, I had enough time to get a fair amount of detail. So those dark things on the edges, that's where I saw this kind of red laser light. And I got pretty accurate on the shapes of the corona. Here's Mars over here, and here's my sketch compared to the cover of Sky and Telescope that came out a little bit later. So as you can see with my naked eye, I was able to see, for instance, the streamer a lot farther. So you can see that in the photo it goes out to here as it fades out, but that was easier to see with my naked eye. The other thing I noticed, which doesn't quite show up in photos, is for that eclipse, to me, the shapes of the corona seemed to almost have hard edges. It wasn't as brushy and indistinct as I was expecting. There was a definite shape to the corona. So again, to choose a place, and we'll talk about Texas specifically coming next, you want the least cloud interference expected according to weather statistics, although you can't control what happens that day. So you want to start out choosing a place that has a decent chance. But in addition, you want a place that's near roads that go for long periods of time within the shadow. So you don't want to be near a road that crosses a shadow and you're in and out of totality really fast. You want to be a place where there's lots of roads that go along the shadow in case you have to move because of a cloud. So we had that. We actually chose our site in Uganda according to that because most people were going to a place where the only road went across the path and it was only a 5-mile wide path. So if you had to dodge clouds, you would end up being out of the shadow really, really quickly. So we chose another location and we were able to run along the path. You want to be close to the center line, as close as possible for the longest totality. You want a nice place to visit, so you want more to your trip than just the eclipse, especially if, God forbid, you get clouded out. And I mentioned the cruises again. So here is the whole Earth map for 2024. As you can see, it's well placed. We're in Texas right here, so easy to get to. Or you can go to Mexico if you prefer. This is one of Jay Anderson's maps of average cloud cover at that time on that day. And just be careful about the colors. Look at the scale on the right. This is not like desert versus vegetation. In his scale, the blues and the greens are the least cloudy, and the sandy colors and the reds are the most cloudy places. So Texas is actually the best place in the entire United States. Mexico is better than Texas. Then he makes these graphs similar to the one I showed you for the annular eclipse. And as you can see, the best weather is expected in Mexico. And you can get to far south Texas, has somewhat better weather. That's starting about here. You get a little bit more cloudiness in Uvalde, and then it drops a little bit again in parts of the hill country. Here's Dallas up here. And I'm going to show you another site I use to estimate clouds at that particular time of day. And then it goes on up and down as you get up to the northeast. So there's all these little microclimates. So ideally you want to be kind of in this part of the map, so that's Texas or Mexico, for the best chance of seeing it. So here is Javier Ubier's map of Mexico. My tour operator that I often travel with is going to Mazatlan for their land tour, and they also have a cruise off of Mexico. So you have two possibilities. They're not doing the United States at all. This is one that I've chosen to plan on my own. And Texas, because I want to take my relatives and friends who have not necessarily seen eclipses or seen very many. Here is a detail from Texas to Missouri of cloud cover, average cloud cover for that day. In the hill country, Kerrville, near Llano, I'm actually going to be near Llano, Uvalde are all kind of okay. And Killeen and Waco are also near the center line, and Dallas is too. Just slightly worse cloud statistics. I'll show you some statistics showing clear, mostly clear, partly cloudy, and I consider anything up to partly cloudy a reasonably good chance of seeing the eclipse. This is, again, here's that same kind of map for Texas. So Texas is not that different from south to north. Your best chances are down here. It gets slightly worse in north, but Texas in general is pretty darn good. So you might partly plan your trip on where you have friends or relatives. I think the best bets in Texas, other than going to South Texas, and let me go back, the reason I didn't choose far South Texas is lack of really great infrastructure really close to the center line. So there is a town, a border town in Mexico, and there's a cross it, but a lot of the real cities are a little bit more off of the center line, so you'd probably still want to be driving to the center line. You wouldn't have that wonderful, nice bathroom with you. So for longest totality with comfort, that's going to be the hill country. So I have considered Lakey. I know that some of our members of the Astronomical Society have already got housing in Lakey. I think they were able to get it 3.5 years in advance of the eclipse. Llano is one of the local best places in the hill country as far as local good weather. Kerrville, I looked at Horseshoe Bay first because I knew it was a dark sky community. It's on the south side of Lake LBJ and is a really nice community. Fredericksburg, I expect to be crowded because it's a well-known uh, tourist destination. There's Kingsland, which is actually what I chose, and I'll explain why, which is on the north side of as the Colorado River exits Lake LBJ. Granite Shoals is on the north side of the small town north side of Lake LBJ. And then again, South Texas is somewhat better, so you can look there also. The next step is finding housing. Though you can always try to go ahead and book hotels. So usually the big Eclipse tours are in somewhat more established hotels. Those may already be sold out in a lot of places, but there's a lot of Texas to look in. So you can often find a modest hotel that's booking. Sometimes they won't book 2 years in advance. Sometimes they say you have to wait for 1 year in advance. And when they wise up, they start price gouging. But we were having a lot of trouble. I called like 6 hotels in Idaho Falls, and they were all saying, no, we're booked, we're booked, we're booked. We've got the day before the eclipse and the day after, but we're booked on the night of the eclipse. And I thought, maybe I need to go to a plan B. So my brother suggested rental homes, which I had never done. So the 2 big rental home sites are VRBO, which I am doing in Kingsland, and Airbnb, which I've done in Chile and in Idaho. So here's my rules. If you want to go that route, now's the time. The price gouging has not started up, and you can often share a house and maybe have it be $100 a bedroom in a beautiful house, in a comfortable place, in kind of a tourist destination. So for each site, it's called a premium host for VRBO or a super host at Airbnb. These are people who have developed a reputation for being excellent hosts, and they've got a reputation to uphold. They have great reviews, and I'm recommending going with them. Definitely tell the owner that you are coming for the total eclipse. Sometimes the owner doesn't even know about it. First, make sure that they know what it is, that they should see it themselves, and make sure that, urge them to see it. Make sure that they will not need that house for their own family, that they already have their own place to observe. They're not inviting a bunch of people to use that house, because you don't want someone yanking the house out from under you. There's still the risk of someone selling the house, and that has happened, but usually you can go to a plan B. Send them eclipse information. I offer to send them eclipse information, some of these sites I'm going to show you, and I often send them like 30 or 40 eclipse glasses for them and their friends, and it creates a lot of goodwill. Sometimes, if it's practical, I'll even invite them to observe with me, but so far no one has needed to do that. They've said they've thanked me, but they've been able to observe on their own. But again, trying to create goodwill. So understand the refund policies. I actually, in a way, find it's almost better to go with one with a more strict refund policy, because they know you're really serious and are unlikely to pull out from under them. But there are some with lax, which like the one I have now, it's like I supposedly withdraw only 2 months ahead. But it had a relatively decent size deposit, so they know I'm serious. And then periodically check your reservation, make sure that it shows blocked out on the calendar, and try to stay in touch with your host periodically over every few months. Make sure they still answer and they're there. So I chose Kingsland for several reasons. It's near a lot of tourist destinations, but I think it's a little bit off of people's radar, so I'm hoping it won't be as crowded as some other destinations. It's a nice water destination, and it's near a number of parks. It's near Inks Lake State Park, Longhorn Caverns. It's a little bit, I believe, southwest of Austin. I think I have to look at the map. But it's on the north side of Lake LBJ, and there's lots of houses right on the water. So I actually initially looked in Horseshoe Bay, and the first person, I told them, make sure you don't need the house. I put down the deposit, and they did turn it down, so I got my deposit back. And I was like, oh, good. I actually wanted to look over water. So at Totality in Texas, at that part of Texas, you're looking due south at the eclipse. So this is a closer up. This is Javier UBA's map blown up more, and this is the data that shows up, and I do have a detail of that. That's close to where our house is, so it's on the Colorado River. When we look south, we'll be looking directly over the river, and here's Lake LBJ down here. This is a detail of the information you get simply by blowing up the map, dragging it to where you want to be, and then clicking on it. So it shows that you are at a spot where the eclipse is total. It says that at this particular spot, totality is officially 4 minutes 22.9 seconds, but there's something, but lunar limb corrected for like the shapes of the mountains, it's actually 4 minutes and 21.8 seconds. So almost 4 minutes, 22 seconds. That's only about 3 seconds shorter than being right at the center line. Then you have a lot of data about exactly what happens in that location. So it tells you the time of the first bite being taken out of the sun. Notice it says C1, start of partial eclipse. That stands for first contact, like we went through. Then the start of the total eclipse, which is really pertinent. It tells you the time that happens in universal time. So that's the time in Greenwich, England, like many astronomical events are listed. And then everybody's supposed to adjust for their time zones. So for Central Texas, I did check it out. We will be in daylight saving time. So we would subtract 5 hours. It's in a 24-hour clock. So subtracting 5 from the 1836, that means it's going to be 1336 or 1:36 in the afternoon at maximum eclipse, so the middle of totality. And then it tells you the time for the end of the partial eclipse. Really pertinent, though, is also the azimuth. 180 degrees or 181 degrees, so I know I'll be looking south at totality, and also the altitude, which is 67 degrees. That means it's going to be 2/3 of the way up from the horizon to the zenith, which is good. You want the sun higher in the sky, gives you a better chance weather-wise, which I'll explain why that is as far as clouds go. And so what I want to show you is why you want to think about terrain a little bit. Jay Anderson says it's a little bit less pertinent in Texas, but I've seen this happen too many times. So people, this is the Australia eclipse. Our hotel was way off to the right, and I noticed this knolls here, and the wind was coming from the south, from the east. This is near Cairns, Australia, on the east coast. And sure enough, what happened is these clouds were all the way, from this point on to the south, and the people say the hotel got clouded out. From the hotel, it looked like over the water was cloudy, but I knew from experience that often clouds will clear out over the water, and it took me a little while, but I did encourage the operator to take a bus up north. So we did find, this is interesting, and you may want to know this. I was worried about there being terrible traffic, but because we made this decision so late, we were traveling during the partial phases, and nobody was on the roads. We were able to go the whole 70 miles an hour. And as soon as we saw the sun peak out, we went over to the beach, and we had a beautiful experience of that eclipse. The other thing you might notice is that actually, if you do have some clouds, it's actually quite pretty. You get more sunset colors. So it's not bad to have clouds as long as they're not over the sun. The other thing that's nice about Javier UVA's map is you can blow it up so much you can go to an individual street corner or a house and find the data for it. Why I want to look toward the water, where I've seen a number of cases, most strikingly in Wuhan, China, where almost all of China was cloudy, but there's a lake in the center of Wuhan. I was watching the satellite map all night long, and the clouds parted around that lake every time and came together. That's because lakes can be a little bit cooler than the land. I don't specifically know about the weather in Central Texas, but I did get, once I got the address to my house, I looked at Google Earth for it, and it was exactly what I've seen happen sometimes. So if you look behind the house, this is my house on the right, on the lake. If you look behind it, and in every direction behind it, where the land rises, it looked mostly cloudy. But in the direction to the south, which is looking to the left of this picture, the clouds look much thinner. And we would have seen the eclipse that day if this were 1:30 in the afternoon. It would have been about up here in this clear spot. So we've had a good chance. Hopefully you have a completely clear day, but on a partly cloudy day, I have seen that often water can make the difference. So being on the boundary of land and water might make a difference in a microclimate, but no guarantees. I just like to start out that way just in case. Turns out in Chile, which was I didn't get to because of the pandemic in 2020, but our host wrote us, and almost all of Chile was clouded out. The few people who saw anything were the ones who went to the south the beach on the south side of Lake Villarrica, and look toward the north, high in the sky. So there's something called the echelon effect. This is why an eclipse is high in the sky, may be less pretty to photograph. You don't get all the scenery. But on a partly cloudy day, just because of perspective, it can look almost overcast if you're looking along the clouds lower at the horizon. But overhead can be a lot clearer, and it's not so difficult to figure out which way to run in case a single cloud gets in your way, like we did in Uganda and also in Australia. We could just get on the road and head in a certain direction. So you definitely have a better chance when the sun is high in the sky of seeing it on a partly cloudy day. So I just mentioned it's about 67 degrees up in central Texas at totality. Now there's another site I like called weatherspark.com, which is full of weather statistics and even historical weather. So here it is for Kingsland. I looked at a bunch of different locations, and it's not that different, according to this site, from South Texas, which is slightly better. Leakey and they show Leakey and Fredericksburg is about 2% better. What I like to look at is from the mostly clear to clear, mostly clear, I consider excellent chances, and partly cloudy, a definite chance. And what are the chances of having a combination of those? So they have that percentage here along this line. Now, when I chose April, I get kind of a range from March to May here. But if I choose a specific day, and it does, of course, the specific day doesn't really mean anything, but what it does allow you to do is now you get average cloud cover by time of day. So in this case, it doesn't make a lot of difference, but you can see that it's a little bit cloudier in the morning. It actually turns out that 1:30 in the afternoon is your absolute best chance. It's only slightly better, but that is the least cloudy part of the day. And that seems to be true of all the hill country locations. So camping is another low-cost way you can do it, but even campgrounds will need to be reserved when there's a total solar eclipse. However, in 2017, anybody who lives on the eclipse path, if they can capitalize on it somehow or give you some way to see it, they will do it. If all the rental houses seem to disappear 1 year ahead, and you feel like, oh my gosh, it's too late, more people find out about it, and new VRBO and Airbnb houses will show up, although more expensive. And some homeowners actually rented out backyard space. They were willing to have people set up tents in their backyards. So that's a possibility too. This is a great general eclipse site. MrEclipse.com is Fred Espenak, who was the eclipse expert for NASA for many years. He's now retired, but these road atlases, among of his publications, are invaluable for chasing eclipses if you're on your own in a car. So I've just ordered the one for 2024. You can get a digital edition. You can save a little money getting the black and white edition. So if say you're leaving from Houston that day and you want to know which roads, where you need to be on the center line, which direction you want to need where all the little roads are, this atlas will be great. If we find we need to leave our house, we're definitely going to use this atlas to decide how to stay close to the path and where to flee weather-wise. Now, you don't have to travel to an eclipse. You wait 1,000 years or so. One's almost bound to come to you, but in any one part of the Earth, on average, you only get one total eclipse, only once every 360 years. So it could be a very long wait, unless you're in Carbondale, Illinois. You also will have eclipse paths cross, so it's possible for one place to get a total eclipse within only a few years of each other. So the 2017 and the 2024 eclipse paths cross in Carbondale. However, Carbondale, Illinois did not turn out to be the best place weather-wise to see the 2017 eclipse. And it's not the best place for the 2024 either. This is the ultimate eclipse imaging. There's a man from Czechoslovakia, from the Czech Republic now, who composites. He does a special technique to get the most detail at every part of the corona. I think he does some compositing or some processing. So he gets almost hyper detailed coronas. This is more than your eye can see, but he has a whole series of these. And one of the things you can see is that the coronas vary quite a bit from eclipse to eclipse, depending on whether it's solar minimum or solar maximum. Some are a lot more round, like with very short petal-like coronas, some have long streamers. So no two eclipses are alike, either culturally or the sun itself. And this is my ultimate eclipse. This is Saturn eclipsing the sun from the Cassini spacecraft. And I'll leave this site up just for a minute or so. If you take a screenshot of it, it has all the useful sites that I use. And I'll just leave this up for a minute and I'll see if there's any questions. And I'll stop my share maybe after the questions begin.
All right, appreciate that, Debbie. If you do have questions, go ahead and come off of mute and ask those. We didn't get many questions in the chat other than Andrew Jones asked when will we be able to get copies of these slides?
I guess that would be possible. So I could, can I get that to you? Is there a way to post them somehow, Joe? Or I can get that to you if you can figure out a way to, a way to do that.
Okay.
To get it to people.
Yeah, we can
or I
certainly
can
do that.
send it to someone individual if they would like through Dropbox or something like that.
Yeah, if you want to send those to me, I'll go ahead and get it distributed to the list. And I went ahead and posted a questionnaire, 2 questions. People are already answering those. Just wanted to know how many of you have seen total eclipses, solar eclipses, and how many of those you've seen, and whether or not you are planning on observing the 2024 total eclipse, the eclipse in totality. So getting somewhere along that path that you kind of showed there, Debbie. But while we're doing that, I'll let anybody who wants to come off of mute go ahead and do so and ask their questions.
Debbie, do you expect Waco be in this line of totality? Waco, Texas?
Sorry, which place was it?
Waco, Texas.
Texas.
Waco is definitely in the path. Yes. Yeah, I have a friend whose son is there, and they're probably going to retire there. Yes, Waco's definitely on the path. You know, the other thing is I should mention that eclipse2024.org is a fabulous all-purpose site. It even has links to a lot of these other sites. And one of the most valuable things it has on it is actual satellite data at that time of day for the last 10 years on April 8th along the entire eclipse path. And what I notice is that of the 10 years, it looks like the cloud statistics are about right. But almost all of the years except one, it looked like it would be possible to dismount and regroup and get out from under the clouds in Texas. I think I only saw one of those 10 years where the entire path was clouded out. So, so if you go to Waco and that's where you have friends or family and it's not great for some reason that day, there's a reasonably good chance you could get out from under the clouds by traveling.
And Debbie, you've got, I'm sorry, the pop-up from the quiz that I just sent out to everybody is blocking the
right. That's why I didn't remove it just yet in case.
Would you mind? Yeah, that way people will be able to see.
Yeah,
those.
that's okay. I was thinking it was
sorry about that.
Yeah, I was going to wait because of the pop-up to allow people a little bit more time to screenshot this page.
Yeah, there we go. So for those of you who weren't able to see this all before, you should be able to see it now. And does anybody else have any other questions?
Yes, would Kingsland be preferable to Waco?
It's a little bit, it's slightly preferable weather-wise. So Llano, for some reason, we're a little bit east of Llano. Llano is not nearly as pretty as Kingsland. You don't have the lake, but Llano is kind of a local dip in the cloud statistics. So it's relatively good for the hill country. And I don't know how the lake is going to affect it exactly. But I think I saw at least one of those satellite photos where it looked like where it was a little cloudy in the hill country, and it looked like there was a thin spot over Lake LBJ. So that's, I just want to give myself that chance in case there's a difference. Okay. It's easy to move. So that's, but yes, Llano's good, and Kingsland looks reasonably good. Now, this does not mean that we'll see it. I mean, you can have 3 days in a row of overcast in the hill country. So it's just, it's just, this is not like when we went to Idaho and there's a 92% chance of clear weather. It's more like a 66% chance of clear to partly cloudy and about 50% chance of excellent weather.
Okay. Debbie, excellent job as usual. This question is a little bit off point tonight, but regarding solar telescopes like the Daystar products, Scout product, Coronado or anything, would you or someone maybe make a comment about that, or maybe another session, another novice session, give us a little guidance on what your thoughts are on that, or the
Yes,
synopsis.
yeah, that's actually excellent to take take to an eclipse for the partial phases. I'm not sure what happens with them. Well, I guess you would see everything at totality also. So I have seen people take those to eclipses, and of course you get a lot more detail on the sun's surface that way. And yeah, I would definitely recommend, and it's definitely safely filtering the sun for looking at it the entire time. Definitely you want to look up naked eye during totality because it would be a completely different. I'm not sure if you see only the corona. I think you would miss, you might see some prominences in the day star, but I'm not experienced with this, but I don't think you ever see the corona. So it would be great for the partial phases.
And Debbie, one of our good friends, Tim Pellerin over at Land, Sea, and Sky, is a pretty accomplished solar imager and observer. So that may be something that we can arrange for him to come on and talk about that as well.
Yeah, I was hoping I'd actually talked to Lloyd Overcash a little bit before he got those bad news about, and he was finally agreeing to do a talk. So thank you for, I would like to do a talk like that.
Okay,
Thanks.
perfect.
And
Great.
is it time for me to stop sharing? Has everybody had a chance to get this screen?
Going once,
I got
going
it.
twice. All right.
Okay.
And I did
stopped
put a
sharing.
few of those links, not all of them, but a few of the links in the chat as well. So if you want to go ahead and click on those and save those links, feel free to do so as well.
Yeah, and eclipse2024.org is pretty easy to remember. So
Yeah.
so that's that has a lot of the links to all these other places too. So I'm going to
Wonderful.
stop the share.
Okay. And we did have the poll pop up. I did share that with everybody. I was just kind of curious to get input from all of you. How many total solar eclipses have you observed? So 27% of you said none. So hopefully you'll get an opportunity to change that in a couple of years. A few of you said you've seen a solar eclipse, but not in totality. You're probably here in Houston in 2017 or some other place outside of the path of totality. 37%, the largest number, said only one. And again, I'm guessing that's the 2017 eclipse. A few of you said you've seen two, and only two of you said you've seen three or more. So yeah, not as many people have bagged as many of those as you have, Debbie. So.
Yeah. Well, I mean, it's not inexpensive to do all the world travel.
Understand.
But I did learn though from those women I met in Australia that you can even go to the other side of the world a lot less expensively than doing the tours. You know, if you can just get your airfare there and get an inexpensive Airbnb, you can do this a lot less expensive for thousands of dollars less.
Perfect. And then the second question, are you planning on viewing the 2024 eclipse in totality? 27 out of 30, 90% of you said yes, enthusiastically. Only one of you said no. I'm surprised.
Well, we have to fix that.
Exactly. Yeah, you've got some big plans, maybe a wedding planned or something like that for that day. And then two of you are not sure. So hopefully you've gotten enough information for those of you who are not sure from Debbie's talk tonight to hopefully convince you to find some place along that center line or near it so you could observe this thing in totality. So
yeah,
any other questions? Oh, go ahead, Debbie. I'm sorry.
I did want to mention, there's a wonderful essay on eclipse2024.org, which is really it's the same site that was up for 2017, about why to see an eclipse. And what I found is when it's hard to convince someone to see an eclipse is they think it's a similar experience to a partial eclipse. And I had a very hard time getting my sister-in-law absolutely refused to come to Idaho. She doesn't like to travel that much, but she said that she swore up and down she had seen a total eclipse when she was a kid, the 1979 eclipse. And I kept telling my brother, I said, no, she didn't see an eclipse. No one, a totality. No one is blasé about it. Yes, she saw a total eclipse. But no, she didn't. And unfortunately, I was writing her and sending her the essay from Eclipse, 2017.org about how it's a totally different animal, and it's, it blows everybody away to see a total eclipse. And no, she saw one. I finally asked my brother, like when it's too late, one day before, I was talking to him from Idaho. I said, well, where was she? And he said, well, she was in Wenatchee, Washington. So I found Javier UBA's map. She was 25 miles. She saw like a 99.9 something eclipse. So it actually went all the way down to almost a diamond ring. but she never saw totality. She never saw the corona at all, and all of the phenomena that happen with that. So she saw a near eclipse, and a near eclipse is not good enough. So a near totality.
Not at all. Are you seeing the screen by
That's
chance?
totally different. Yes,
Are,
yes.
are you seeing the map of the eclipse path on the screen?
Yes.
Okay, so this is that eclipse2024.org website. And in here, you do have an interactive map. I can zoom in, take a look at places along the center line. So, it doesn't have all of the weather information, but if you're just wanting to get a general idea of where you might want to start looking for housing and lodging and things like that, you can find lots of places here. So the center line is indicated by this blue line, and then the shaded in areas that are bound by the red lines are where you would experience totality. So obviously, as Debbie had mentioned, the closer you are to this line, the more of the totality you're going to be able to experience, and the further along on this edge, the lesser it would be. Okay. What other questions do we have for Debbie?
Hey, Debbie, do you have any experience or comments about videoing the people who are watching the eclipse?
Yes. Actually, my first eclipse, and what we recommend is to set up on and I haven't actually done this. I've done tape recorders. You want to hear the people, so you want something with sound. You want to enjoy the sounds of people enjoying the eclipse. So a good thing to do is to set up a tripod with the people looking at the sun. The tripod sees the backs of the people, and they're looking at the sun. So you get the whole scene. You want something very wide field, and you'll see the whole shadow swing around the sun, and you'll see totality will not be anything like what you see naked eye, but you'll get the effect. And the cell phones are getting pretty darn good these days to get a really nice picture. And so I've seen some videos. Look on YouTube. There are videos where people have done that. They've set it up behind the crowd and looking toward the sun. So you're looking at you want to see people from the back for that kind of thing if you want the sun in it also. And the other thing is for etiquette, is you want to avoid all flash cameras because people want to have their kind of night eclipse vision. You certainly don't want to flash in your eyes. And the other thing is if you're in a city, stay away from those darn LED street lights. They will come on, and you definitely don't want one between you and the sun.
That's true. Absolutely. Absolutely.
Debbie, one more quick thing. First of all, great presentation, of course. You really gave us the information we need. On the subject of somebody who could go to see it, but decides not to see it because partial is okay, I saw the best thing, I think it was an astronomy magazine a few years ago. Somebody was talking about it about 2017, and he said the difference between seeing totality and a partial eclipse is like the difference between dying and not dying. Okay?
Yeah, exactly. Yeah,
it seems close, but it's extremely different.
Yeah, extremely different. There's no comparison. So all eclipses are interesting, but totality is emotional because it's not just, first of all, it's so physically beautiful. And then it's hard not to be emotional about the coincidence that's involved. My roommate, I saw her give a talk. She has a coffee house talk on YouTube. And at the end, she says, you're looking at you saying, is this God? It's just phenomenal. It's just, even the fact that we have something like that happening the coincidence is mind-boggling that it can happen, and then it's stunningly physically beautiful when it does happen.
Yeah, and you can't get the emotion on the internet or in photographs afterwards. You got to be
right. There. Yeah, I kind of object to doing talks with a lot of photographs and videos, because I think that's the reason people don't go to them. They are pale. They just don't do what you actually see when you're there.
Absolutely. I had the privilege of watching the 2017 eclipse in the Grand Teton area that you'd mentioned, and just everything leading up to it. The way that the environment changed as it darkened, you could hear wolves starting to howl, birds were acting strange, and then once you hit totality, like you said, the emotional response a lot of people had. There were several people that just started crying. It was that much of an emotional response. It was absolutely incredible. So, like you said, Bill, the difference between 100% and 99% is like the analogy you use. So, Just doesn't compare. So, all right. Any last questions for Debbie before we wrap up tonight?
I can echo what a lot have said. It was a very nice presentation.
Thank you, Tom.
Thank you.
Appreciate it.
Thanks.
Yeah.
I enjoyed it. My first eclipse was in '99, and I went to Austria and to Salzburg, and it was overcast and rainy and horrible.
Mhm.
But the skies cleared up like Moses parted the sea. And it was a beautiful, wonderful eclipse, and since then I've been addicted. So I'll go whenever I can.
Yeah, I'd like to mention that for 3 of my eclipses that I saw the day before, the forecast was for total overcast, and I still saw them. So I've now been clouded out twice, because in Antarctica and the ocean, we were 14 out of 15 ships were clouded out. But I've only been totally clouded out twice out of, I can't remember, that was 14 or 15 at the time. So
I said that I observed 2, but I planned 3. So I was clouded out on 1.
yeah, I was lucky, and it took me a while to be clouded out. So a number of them have been in real desert areas where the chances were excellent. But I've seen all the ones where, just about all of them where there's a reasonable chance of clouds too. But there's a lot of latitude. You can move around. There's a lot you can do to maximize the chances that you see it, short of being hundreds of miles of overcast.
All right. Well, thanks so much, Debbie. That was a wonderful talk. Hopefully everybody got all the information they needed to start planning their trip. They've got links to those websites that you'd put out there, and we're armed with a lot of great information to make decisions on where to go to observe this thing. So thanks again, Debbie. Another wonderful presentation. All right, folks. Well, I wanted to wrap up here, but before we do, I just wanted to mention that this Saturday, June 4th, at our good friends at Lansing Sky in Houston off Richmond Avenue, they're having an event called Dabapalooza. So many of the local astronomy clubs are going to be there. The Houston Astronomical Society will certainly be there as well. Bram Weissman is kind of leading the charge for our volunteers. But if you'd like to come out, please do so. I think the event starts at 10 o'clock. We're going to have Dobbs and Donuts, several events. And then starting at around 4 p.m., they'll have some lunar viewing and observing with the Dobsonians. So safe observing. We're not going to point them at the sun or anything like that. But that'll be going on this Saturday at Lansing Sky. And I also wanted to mention that tomorrow night we have our general meeting, and that is going to be a hybrid meeting. So we're going to be in person at the Trinity Mendenhall Center there off of Wart Road, and we'll also be live streaming it as well through Zoom. So if you can make it there in person, we'd love to have you join us. If you can't, please register, join us online, but it's going to be a wonderful presentation. F. Don Cooper, who has visited us before. I think he was the last speaker that we had prior to COVID really ramping up the way it did, will be our guest speaker. Mr. Cooper was a member of the Apollo program. He actually developed the calculations to determine the orbit of the Apollo missions to get them there safely to the moon and back. He also won the Presidential Medal of Freedom for his work in bringing the Apollo 13 mission back to Earth after the accident that they had there. So that's going to be happening tomorrow at the Mendenhall Center. Starts at 6:30. So unlike most of the online meetings, we're not starting at 7. It will be at 6:30. And lastly, if you are on any of the social media platforms there, please give us a follow. You can see the ones that we have listed there. And if you have any questions, you can always email us, info@astronomyhouston.org. So Debbie, when you get those slides over to us, I'll go ahead and distribute that to the Astro List. So be sure to be registered for the Astro List, otherwise you're not going to get it. But we'll go ahead and distribute those there. So if we don't have any other questions, we will see you all tomorrow night. Thank you very much, folks.
Good night now.
Have a good
Bye,
night.
everybody.
Bye-bye.
Thank you.